As a small boy, I listened to a radio science program describe the mysterious Young's experiment. It seems that light, when passing through a screen with two closely spaced parallel slits, formed a pattern of stripes on a second screen placed beyond the first. One slit gave only a broad band of light, so opening the second slit made the light go out in the dark stripes. The pattern was built up from innumerable spots of light, each coming from a single photon. The question is, how does each photon, which is small enough to come through one slit, know that the other slit is open? Here is an intriguing mystery that adults could not understand and still cannot explain. Now, decades later, I found the answer to this and many other unexplained phenomena that form the bedrock of our understanding of the universe in which we live. The most important fact that escaped comprehension is that the universe has 4 dimensions of space, all of which are at right angles to one another. Let me explain. A dimension is a direction in space measured in, say, meters. To define a dimension, we must first choose a starting point in space to make the origin. Our first dimension could point in any direction, but for the sake of illustration, let us choose in our imagination a horizontal line pointing due east. The second dimension could point in any direction that does not go due east or west at all. Let us choose a horizontal line north-south and crossing first at the point of origin. The third dimension is now exactly defined as a line running vertically up and down from the point of origin. We now have 3 directions which are all at right angles to one another, but we cannot see another direction which we can call the 4th dimension of space. With 3 dimensions we can define a point on any object, but we cannot move the object from place to place or even create or destroy it. For this we need time. So time must be associated with the 4th dimension of space. The questions are, how can time be measured in meters and in which direction does it point? To convert time in seconds to meters, we must multiply by speed, measured in meters per second. The units of seconds then cancel out, leaving a distance in meters. But what speed should be used? If we try a slow speed, say 1 meter a second, then we could walk fast enough into the future, find out what happened, return to the past and change it. If we use the speed of light to convert time into space, it would explain why we cannot see the 4th dimension. To see further forward in the 4th dimension, we would have to have light that travelled faster than light and then return to us. This is impossible as, by definition, light moves at the fastest speed, and of course there is nothing there yet. If there was something in the past sending out light to us, this light could never catch up, so we can see neither forwards nor backwards in the 4th dimension. Lorentz took the distance in the 4th dimension to be time multiplied by the speed of light in his equation for distance in space between 2 events. This means that even if events occur at the same place, the distance between them, taking into account the 4th dimension, is about 300 million meters for every second that passes. So we not only live on the edge of the expanding universe, but we are made from a zero-thickness surface that is the edge of the universe, and so cannot see or point in the direction of the 4th dimension of space. Einstein did not believe in the expansion of the universe until Mr. Hubble showed him that all stars were going away from us, and the further away they are, the faster they go. So it's not surprising that he did not mention that what he called time is just the 4th dimension of space. Time is therefore how we perceive distance in the 4th dimension. So the ticking of the clock marks out the distance moved through the 4th dimension of space. If the universe is just an insubstantial surface, we must ask of what is everything made. There can be no bumps or protrusions outwards because nothing can go faster than the speed the surface is already going. But we can go sideways. That is movement along the surface from place to place. There is only one velocity in 4-dimensional space. Speed through the 3-dimensional space only changes our direction through 4-dimensional space. The question now is, how do we make fundamental particles of matter, such as the electron and positron, from the surface of a four-dimensional sphere? Electrons and positrons are made in pairs by the interaction of two X-ray photons. The way the X-rays do it turns out to be right before our eyes every time we stir a cup of tea by moving a vertically held spoon across the diameter of the cup. Just one movement shows that two whirlpools are formed, one on each side of the spoon. The whirlpools quickly die away due to friction. But what if there were no friction? Very cold liquid helium has no friction, and there the whirlpools last as long as the liquid remains cold. The whirlpool spins faster and faster in the center until it reaches a limit. In the case of liquid helium, the limit is the size of the helium atom. But in the case of space, the limit is set by the speed of rotation reaching the speed of light. Rotating at the speed of light fixes the center of the particle in four-dimensional space, so the center of the particle is left behind by the ever-expanding surface of the rest of the universe. However, the center of the whirlpool remains joined to the otherwise flattish surface of the universe by an ever-lengthening tube of space which widens and slows as it reaches the flat surface. This simple whirlpool model of the electron allows many of the otherwise incomprehensible properties of the particle to be understood. Why do particles with mass attract each other? Well, the surface of the universe must flow into the whirlpool because the tube joining the surface to the center is forever lengthening. The surface accelerates as it approaches the particle because the same flow has to fit into a smaller volume. This acceleration of space in the vicinity of mass is the acceleration we call gravity. So space falling into mass explains gravity. There is no other explanation for gravity. Objects with mass can alter the direction of light and slow the speed of light. Light must follow the surface, so any distortion of the surface will lengthen the distance that the light has to go. So gravity appears to slow the speed of light. In fact, light does not slow, but has a longer distance to go than expected when it passes close to an object with mass. This is the bending of space by mass. Have you ever wondered in which direction mass bends space? The answer is that mass bends four-dimensional space into the past. The force of inertia was defined by Newton as the mass of the object multiplied by the acceleration of the object. This inertial force comes from nowhere, but can be understood now that we realize that the mass does not exist at a point, but is distributed through space, like a whirlpool or a hurricane. Movements of the center cannot instantly cause the outer regions to rotate about the new center of rotation. The outer regions of the whirlpool must interact with the inner regions, giving a force when the center is accelerated. This is the inverse of gravity, where the outer regions are accelerated and the center remains still. The equivalence of gravity and inertial forces was demonstrated by Galileo, who simultaneously dropped objects of a different weight from the Leaning Tower of Pisa and showed that they took the same time to fall. This experiment was commemorated on the Moon, where there is gravity but no atmosphere, by an astronaut who dropped a feather and a weight which hit the Moon at the same time. Electrons carry electric charges which can be either of negative or positive polarity. Electrons are negatively charged and positrons are positively charged. Objects which are electrically charged experience forces which pull them towards each other or push them away from each other. The rule is, like charges repel while opposite charges attract. While the amount of force is known, there is no explanation as to why it occurs until now. Nobody understands how an electron can hold together, as immense force will be needed to stop the electric field from blasting the particle apart. Well, the whirlpool has a center that is rotating at the speed of light, so it can be held at one place in four-dimensional space. Time has stopped at the centre, nothing can happen, so it cannot change at all, let alone be blasted apart. The electric forces between electrons and positrons are caused by the surface of the universe having to rotate about two centres. Each whirlpool is a centre of rotation. Imagine space to be an ice rink and a lady ice skater holding by a rope to the nearest centre of rotation. If the whirlpools have opposite rotation, the space between them is moved in the same direction by both whirlpools, so the skater has to hang on tight as she slips quickly between the centres. The rope on which she pulls will draw the centres together, so particles with opposite rotation will be drawn together by the movement of the surface about both centres. If, on the other hand, the centres are rotating in the same way, then the movement of the space between them will be slowed by the presence of the other whirlpool. In this case, the skater would dawdle when passing between the centres, but would have to hang on tight when on the side farthest away from the other whirlpool. The rope in this case would pull the whirlpools apart, so particles with the same rotation would repel each other. This attraction and repulsion is the same as the behaviour of charged particles, so I ascribe the electric field as being due to the rotation of the surface of the universe around two whirlpools. The Lorentz equation established that, while apparently stationary, objects are moving at the speed of light in the fourth or outward dimension of space. Moving through three-dimensional space adds a velocity that is at right angles to this outward direction. Relative velocity is associated with a different direction of movement through four-dimensional space. Relative velocity allows the rotation of the whirlpool to affect us because the axis of rotation has a component in three-dimensional space. These effects are the magnetic field, which generates a force that points in circles around the direction of movement of a moving charge, and the wave nature of a moving mass, which gives moving particles a periodic length in the direction of movement of the particle. The magnetic field is that portion of the electric field that occurs in three-dimensional space because relative velocity has rotated the direction of the moving charge in four-dimensional space. The magnetic field strength is calculated simply by multiplying the velocity of the charge by the electric flux density. So the magnetic field is a moving electric field. An electrically conducting wire has electrons that can move from atom to atom, but the atoms themselves are stationary. In this case, the magnetic field from the moving electrons is greater as the electric force is cancelled out. Electrons moving in two wires interact through their magnetic fields. The magnetic force is calculated by multiplying the magnetic flux density by the current flowing, and also by the length of the wire through which it is flowing. Particles also rotate in three-dimensional space, so electrons have a rotating field in three-dimensional space. This makes the electrons into magnets, so they tend to align themselves with the prevailing magnetic field. When the electric current accelerates, it generates voltages in other wires in the vicinity. Acceleration of an electron alters the flow of the surface of the universe. Changes in the flow of the surface accelerate other electrons. This action makes for an interplay of forces whenever a charged object is accelerated. While the magnetic field is changing, all the other electric charges are moved as they accommodate to the new situation. This is the effect that forces electrons along a wire when the magnetic field at right angles to the wire is changing. It is the dynamo effect which gives us electrical power to run our society. Changing an electric current sends a wave of change across the surface of the universe, which radiates away from the source at the speed of light. Alternating electric currents give radio waves, and at higher frequencies the radiation is called light. Electrons orbit the atom much as planets orbit the sun. except that the force attracting them to the centre is electrostatic rather than gravitational. Inertia gives an outward force as it tries to keep the particle moving in a straight line. As a consequence of the periodic length of the electron's orbits can only be stable if the circumference has a whole number of wavelengths. This means that the electron must acquire or release a precise amount of energy when changing between these exactly defined orbits. Optical radiation is therefore associated with the exactly defined energy packets called photons. An electron-positron pair is formed by the collision of two X-rays. Conversely, the collision of an electron with a positron forms two X-rays. This is the basis of the PET scan. That's positron emission tomography. An electron is an X-ray which has been reflected through 90 degrees and changed from moving in three-dimensional space and is now moving in the fourth dimension. The frequency of the X-ray is modified by the Doppler effect. The Doppler effect raises the frequency of an approaching oscillator and lowers the frequency of an oscillator that is moving away. A moving particle appears in three-dimensional space to be made from the addition of both the approaching and retreating Doppler-shifted versions of the X-ray's frequency. These frequencies add to zero periodically along the direction of the path of the electron. The periodic length of the electron is the distance between these zero amplitude positions. For more than a century, a debate has raged as to whether the electron is a particle or a wave, and here is the answer. An electron is a particle moving in four-dimensional space, which is also oscillating in three-dimensional space. As such, relative velocity makes the position of the particle uncertain, and due to the summation of Doppler-shifted frequencies, gives it a definite wavelength for a definite velocity. Both kinetic energy of a moving mass and radiant energy of a moving particle have a periodic length. As whirlpools, particles have small centers but extend over great distances. A photon travelling at the speed of light does not experience time or distance, and so is indestructible. Yet objects with mass are opaque. Light is reflected and radiant energy is absorbed. Opaque objects must generate another photon which exactly cancels out the original photon. However, the cancelling photon cannot be created in isolation. To maintain symmetry, two photons must be created. This process can be seen in the case of a mirror. The reflected light is not the incoming photon changing direction, but a new photon generated by the reflecting surface as it reacts with the incoming photon. Indeed, the reflection of circularly polarized light from a mirror is rotating in the opposite direction to the incoming photon. Scattering of X-rays from an electron gives the electron kinetic energy, so the outgoing photon even has a different frequency or color. Light appears to slow down when passing through a medium with a refractive index. This slowing down is the result of innumerable reactions in which the photon is recreated as it interacts with the atoms of the medium. Each time cancelling photons are generated, the atom assumes a new configuration which is not stable, and a new photon that mimics the incoming photon is generated and passes on to the next group of atoms. This process takes time, so the photon that emerges from the medium has been delayed by its apparent passage through the medium. For absorption, the atoms retain some or all of the energy of the incoming photon. When energy is absorbed, the process of cancellation changes the orbits of the electrons in the atom. The electron which receives the photon may be fixed in a new orbit, or the whole mass of the medium may vibrate, i.e. the medium warms up. The ability of light to interfere with itself, given two or more paths over which it could travel, which started my interest in physics, is just another example of light interacting with mass. The light, being made of rotating electric and magnetic fields, interacts with all the charged particles that constitute the path over which it passes. So, in the case of Young's two-slit experiment, the photon of light does not go through the slits as an independent entity like an arrow through an arrow slit on a castle wall. The photon is more like a pressure wave that bangs the whole wall, slits and all, so it does not have to choose which slit to go through. As a result of this excitation, the wall generates a new photon, which it sends off in a direction that depends on all the charges in the wall. So the sides of the slits work in concert to generate an outgoing photon. The observed result is a scatter of photons which have low or zero probability of occurring in the directions which are the dark stripes. The periodic nature of moving mass means that interference is also associated with the position of particles with mass. In this case, the mass itself does not have to be destroyed and recreated during the encounter. Only the Doppler-shifted electromagnetic wave, which defines the probability of locating the particle in a given place, is involved. The electron is free to rotate about an axis in three-dimensional space, and because it has mass, it has angular momentum. The rotation of the electric field produces a magnetic field dipole, so the electron acts like a spinning top with a magnet pointing along its axis of rotation. The ratio of the magnetic to the inertial forces of the top is called the gyromagnetic ratio. If the electron is placed in a magnetic field, its intrinsic magnet tends to align the magnetic axis of the electron with that of the externally applied magnetic field. However, the angular momentum makes this aligning force precess the magnetic axis of the electron around the direction of the applied magnetic field. The precession of the electron's magnetic dipole can be detected and its frequency used to measure the strength of the applied magnetic field. This is the principle of detection used in magnetic resonance scans of the human body. In this case, the strength of the signal is used to measure the amount of hydrogen present, and it is the proton in the nucleus rather than the electron which generates the signal. So far, I have described electrons and photons with passing reference to the atom. Nuclear particles are found at the center of each atom and can exist as free particles. These nuclear particles are protons and neutrons and behave as though they had a mass that is about 2,000 times heavier than the electron. Protons have the same electric charge as a positron, and neutrons have no net charge, but do have a strong magnetic field, which can only arise from electric fields, so neutrons must have equal positive and negative electric charge. An electron can only be made from X-rays if a positron is also made at the same time. But positrons and electrons change back into X-rays when they meet, and so there are very few positrons about. The question is, where did all the positrons go? Similarly, where did all the antiprotons with a negative charge go? The only reasonable answer to these two questions is that the positrons are contained within the protons. The universe had to settle down with one polarity or the other, and positive protons with negative electrons is the way it turned out. Assuming that the proton is made from electrons and positrons, with one more positron than the number of electrons, let us consider how a proton could be made that would be consistent with the measured properties of the proton. The most obvious property is the large mass of the proton compared to that of the electron. Well, mass is a movable feast. When stationary, the mass is associated with the energy of a photon moving in the inward direction against the expansion of the universe. When moving at low speeds, the kinetic energy is given as half the mass times the square of the relative velocity. At higher speeds, the kinetic energy is much more dependent upon the velocity. However, it's inconvenient to think of a complicated velocity function, so these additional energy terms have been associated with an otherwise steady mass. So the convention has arisen saying that the mass increases when the relative velocity approaches the speed of light. So the mass of the proton could be due to at least two positrons rapidly orbiting one electron. The orbiting positrons are attracted to the center by the electric field of the central electron, but are repelled from each other. The increased mass defines the velocity, and the balance of the electromagnetic attracting forces against the inertial force to keep it in an orbit defines the radius. To be stable, the positrons must have an integer number of wavelengths around the circumference. The mass increase defines the velocity, which in turn defines the wavelength, and taking into account the effects of moving at a speed which is very close to the speed of light, my calculations show that a stable orbit exists with 2 wavelengths per orbit. So the proton seems to be simply the result of 2 positrons orbiting a single electron. This implies that the electromagnetic field close to a proton might be more complicated than a straightforward electric field, which in turn opens the possibility that the strong force, quarks, gluons, and the rest that are supposed to be associated with the protons might just be figments of the imagination of the physicists. Disrupting the proton would release the stored rotational energy. The positron and electron fragments of this disruption would recombine to give energy in the form of X-rays. This direct conversion of mass to energy would be a colossal source of power. The proton is very strong because it can withstand the conditions inside a star. This does not rule out the possibility of supplying energy in the correct way to cause disruption. This argument also goes for the neutron, which is easy to disrupt as in isolation it has a half-life of only 10.4 minutes compared to the infinite half-life of a stable proton. In conclusion, I think the ideas that sustain our understanding of the universe took a wrong turn when the 4th dimension was classified as time rather than space. I am at a loss to understand why this elementary error is perpetuated. This description has probed the possibilities of treating the 4th dimension as space, and so has made sense of many of the results which are otherwise a mystery.